Hi, welcome to day 11 of 12 days of single message transforms, videos and blogs. My name is Robin Moffat, I'm a developer advocate at Confluent. And today I want to introduce you to a new functionality that came out in Apache Kafka 2.6 in which you can apply predicates to the single message transforms that we use. So by default and previously, any single message transform would be applied to all records passing through. Whereas now in Apache Kafka 2.6 and so Confluent Platform 6.0, you can specify a predicate which is evaluated first before a transformation is then applied conditionally based on that predicate. So the predicates, there are three different ones that ship with Apache Kafka, but just like the transforms API, which you can extend and write your own transformations, you can also write your own predicates. So let's see what this actually looks like. The scenario here is probably quite a common one where you have data in different Kafka topics and it's the same logical entity. So you want to unify that data, writing down to a target system into the same target object. So here the data looks like this. On the left-hand side, we have data in a topic called day11-sys01. If we have a look at that, you can see it's got a source field which says it's from sys01. We've got a field called amount, and we've got a field called product. We've got some other fields as well, but pay attention to those ones. On the right-hand side, we've got data in a topic called day11-system-B, and the data here, we can see the source field says it's from system-B. And then we've got a field called cost, and we've got a field called item. Now, because I've done my work as a data engineer or business analyst, I know that these fields are actually logically the same. So item here and product here, it's the same information, just a different field name. And cost over here and amount over here, also logically the same. So we want to write a sink connector, which is going to stream data from both of these topics down to the same target object, and it's going to figure out renaming those fields. Now, in previous episodes of this, we saw how we can rename topics into a different one. So we can overcome the issue that they're in different topic names because the topic name is usually used as the target object name. So we can fix that bit. We can say, well, never mind what the topic name is. We're going to override that so that both the two different topics write down to the same target object. That's fine. But how do we say, well, we're going to keep one of these field names and we're going to change the other field name? Let me illustrate this with the actual code because it'll become clearer. It's a JDBC Sink connector and it's going to pull in data from any topic that matches this regular expression. So it's a fairly broad catch-all. We're saying if it begins with day 11 dash, then we're going to include it here. So that's going to pick up the data from those two source topics that I showed you, sys01 and system-B. Then what we're going to do is we're going to say we're going to rename the fields from the data that comes from system-B, and we're going to rename the target topic. But we're going to do it a little bit more complex than previously, because we're going to say, well, rename the fields from system-B, we want to rename item to product and cost to amount. But by default, single message transformations apply to all messages passing through the pipeline. But what we want to do is we want to say, well, if the data is from system-B, then apply the rename. If it's from sys01, don't apply that rename. So because we've got multiple topics coming through, we actually want to apply this predicate based on the topic name. If it's from this topic, apply the transformation. If it's from that topic, don't apply the transformation. So we say, well, here is our predicate that we're going to specify. So we say we've got the same transforms here, so transforms, and then the label goes here. So transforms.label.type specifies our type, .renames specifies that configuration to rename those, and then we have a new configuration property which is added in Apache Kafka 2.6, Confluent Platform 6.0, which says predicate. So predicate, we now specify a predicate name, and we're going to define that predicate in a moment. So it's kind of analogous to this here, where we specify a list of transforms, and the transforms are just a list of labels. Here we're specifying a predicate that's associated with this particular transformation, and it's just a label. So we need to define that in a moment. Then we specify a transformation, which is going to rename all of the topics that pass through this into a topic called transactions. So that topic name transactions becomes the target object to which we're writing the data. So we've got the transforms, we're going to rename these fields, and then we're going to rename the target topic for all of the topic data as it passes through. So what we need to do now is actually define that predicate. And we're going to do that, and it looks like this. So we say we've got predicates, and just like we said transforms and we've got a list of labels, we've got predicates and a list of labels. Here's this one here, which is what we referenced in that transformation up here. And then we say there's predicates here, we specify predicates, prefix, and then the label here, and then it's got a type. And there are 3 different predicate types that ship with Apache Kafka. We've got this one here where we match based on the topic name. There's another one which matches based on whether the record passing through is a tombstone record with a null value. And there's another one which matches based on a header key being present. So Kafka messages can have headers, and you could say this transformation predicate evaluates to true if a header with this particular name is present. So here we're matching on the topic, and we're saying if the topic name matches system B. So we've got a little regex on the front there, so anything dash system B. So let's just recap. We're saying as the data passes through this sink connector, we've got 2 transformations. The order actually matters, because we're going to rename the topic. We're going to rename the topic for all messages, and we're going to do that with this rename topic here, which says rename it to transactions. If we do that first, then our second one isn't going to fire, or the predicate's never going to evaluate to true, because the predicate is based on a topic name. So we need to do that one first. So we're going to say, first off, apply this transformation. We apply that transformation, it's doing a rename of fields, and that will only execute if this predicate here evaluates to true. That predicate is defined down here. So we list out our predicates with a list of labels. We've just got one. So this is our predicate. The type is if the topic name matches, that's the class. And the pattern that we're applying there is if the topic name matches this regular expression. Hopefully that makes sense. Go and have a look at the code on GitHub, because it lays out the configuration like this. And you can see what's going on. But now when this runs, we're ingesting data from 2 topics. As the data passes in, it will say, does it match, is it from this particular topic? If it is, apply the rename. And then regardless, because on our rename target topic here, we didn't have a predicate specified. We just said, rename this to that. And now we can go and have a look at our data in our target and say MySQL, and say show tables. I've got a table called transactions. So that is our topic rename having worked, saying, well, day 1-sys01 and day 11-01, day 11-system B, rename those topics into transactions. And if we go and have a look at the data in it, or the schema in it, describe transactions, we can see we've now got amount and product. So we've said if it was from system B and it was called item, rename it to product. If it was from system B and it was called cost, rename it to amount. So that's a bit more of a kind of a considered example of what you can do with single message transforms and predicates combined. I want to show you something, just a little by the by, something else that was added in Apache Kafka recently is in Kafka Connect. You can look at which topics are being handled by a particular connector. So this is really useful in this example, because if we remind ourselves what that connector looked like. And we're finished with transforms and predicates for the moment. I'll come back to them shortly. Now I just want to show you something with Kafka Connect. We have this topics regex here. So we're saying pick up topics that match this. And in my little test environment, if we have a look at the topics that I've got, we've just got a handful of little topics. So we've got a bunch of internal ones, and we've got these ones here. So we can look at that. It's like, well, I guess it's going to match those two. But it can be useful, particularly in a bigger environment or where things have been running, to actually say, well, for this particular connector, which topics is it actually using? So if it's a source connector, which topics is it writing to? If it's a sink connector, which topics is it reading from? So our connector, let's pull this in here, our connector is called this. So this is the name of our connector. And we need that because now I'm going to scroll through my bash history, and I think it looks like this. So it's connectors. So this is the REST API, and I actually made a video about this, so you can go and check that out. And if we do this, so here's my Kafka Connect worker, the connector's endpoint, we specify the name of our connector, and then it's just /topics. And it says here are the topics that that connector is using. So it's in JSON, so let's pipe it through JQ. So you can see these are the two topics that that particular is actually reading from. So that's another useful way to validate what's going on, particularly if you wanted to debug and you've got predicates based on topic names and you're not quite sure which topics are passing through. That's another useful way to look at things. Let's have another look now. Let's come back away from Kafka Connect stuff into Kafka Connect single message transforms and specifically predicates. I mentioned there was another predicate that you can use which will look at and evaluate true if a message passing through is a tombstone message. Now tombstone messages are a special thing in Apache Kafka, and it's where you have a key optionally and a value, and that value is null. Now you'll usually have a key because what these kind of tombstone messages are, they're denoting for a particular key, a particular business key usually, that you want to make it null. So if you're sending through deletes to a target system, you would say, here is the key for this particular record, delete it. So tombstone it. And it's got special things in compacted topics and all sorts of stuff like that. So what we can do is we can say, if the message passing through is null, drop it. That's useful where you perhaps have null messages coming through, maybe erroneously, maybe for a good reason, but for whatever reason, you don't want those null messages to make it through the Kafka Connect pipeline. So perhaps at ingest, but particularly at egress, target systems sometimes get upset if you send them null messages without handling them correctly. An example of that is the JDBC Sink connector. If you start sending null messages across without telling it what to do with them or kind of configuring it so it can handle null messages, it can take a null message and treat it as a delete and do clever stuff like that. But by default, using the configuration I'm about to show you, it will actually throw an error if you give it a null message. So let me show you what that looks like. Here we've got data in a new different topic, and this is data in a topic called sys02. So I'm just going to run a consumer now, which is going to show us the offset of the message, the key, and the payload. So in our source topic here, if I pause the screen there, because that gives us enough data, you can see at some of the offsets and for some of the keys, you have a null value. Some of them have got data in, and that's fine. But if we just watch that data as it passes through, you'll see we get sporadic null messages coming in, and we don't want them. So here's another one there. There's a null message. There's a null message there. We don't want those to go down to the target system. Okay, so single message transforms, perfect for dropping messages as they're passing through your pipeline or modifying messages, but here we're going to drop them. So what we're going to do is we're going to say, let's create ourselves a sink connector. In fact, let me show you what happens if we route it down to our target without what we're about to do with the transformations. So there's our default configuration, JDBC Sink connector, read data just from this particular topic, and set that going. So we've created the connector, it looks fine, but if I go and have a look at the REST API to see what the status is, we can see the sink connector here, whilst the connector is running, the logically running, the tasks have failed. Why have they failed? Let's go and have a look at the Connect worker logs. So we're going to go and have a look at logs for Kafka Connect. Because I'm running it under Docker, I use Docker to pull out the logs because they get written to standard out. And we're going to page up through here, and I'm just going to search for error. So there is my error. When you're debugging Kafka Connect, task is being killed and will not recover. That just means the task died. That doesn't actually tell you why. You have to page up for that. So let's page up. And it says here, we've got a problem. We're exiting the worker sync task because there is an exception. The exception was a connect exception. This sync connector here, it's configured with a bunch of stuff, and therefore you've got to send it a non-null value. Okay, and we didn't. We sent it a null value. Some of the values were not null, and that's fine, but we sent it a we sent it a null value, which breaks things. We could configure the connector to handle nulls, but actually we just don't want to send those nulls through. And there'll be other target systems where you don't want to send nulls. So that looks like this. We're going to modify that connector. So we're just going to use a curl. We're going to put against the REST API just to override the existing configuration. Data from the same topic, and now we're going to say we've got a transform here to drop null records. So that's the name of my transformation. I could call it foo, I could call it bar, it's just a label. For that transformation here, we say the type is filter. So this again was added, I think in Kafka 2.6, I'd have to go and check, but what filter does is it drops records. So if you just set this running now, you would get no records passing through because it would hit that transformation. The transformation says drop the record. But the whole point is we use this in combination with a predicate. So now we say this transformation here, it's got a type filter, drop the record, but this transformation here, it's got a predicate. So dot predicate is a universal configuration that you can use with transforms. Just like transforms have always got a type, transforms can also always have a predicate. So this transforms here, this one here, it's got a predicate of is null record. I've just given it a label. I could also call it foo, although calling that foo and that foo would be pretty stupid because it would get really, really confusing. But it's just a label. So is null record is the name of my predicate. We define my predicates here. So predicates, we've got one called is null record, and then we define it. So predicates dot is null record. It's got a type, and that type is RecordIsTombstone. So unlike the previous example, where we were basing it on the topic name matches and we supplied a regex to match for the topic name, here we're simply saying RecordIsTombstone. Doesn't need any additional configuration. Either it's a tombstone or it's not. So now when we set that running, and we're going to have a look at the status of it, we'll see that our sync connector here is running. Now this is kind of a difficult one to actually go and look at the data. I suppose we could look at the source data and the sync data and line them up side by side, but for now just take my word for it. We can see that it's not failed. And the reason it's not failed is we're dropping out those null messages as they pass through the pipeline. I'd like to finish off by showing you one more transformation. So this transformation is actually part of Confluent Platform. Everything else I've shown you so far is part of Apache Kafka. This one is part of Confluent Platform though. And what it lets you do is it lets you filter messages, and rather using predicates, and for predicates that ship with Apache Kafka, we've seen you can match on topic, you can match on a header key being present, and you can match on is the record a tombstone. With this particular single message transform I'm going to show you, you can actually filter out messages based on the data in the message itself. So that can be really useful. So let me show you what we're going to do. We're going to filter out the data as it passes through from one of our source topics, and we're going to filter out that data, and we're going to say we only want to pass through messages that have got a certain value, a regex value, in one of the fields. So it looks like this. Here is my source topic, and let's go and have a look at that source topic actually before we get carried away with ourselves. So we're going to consume, we're going to use Kafkacat to consume our data. We're going to paste in the topic there, and we're going to say just show me the payload. Quick recap on Kafkacat, super tool, lets you produce data into Kafka, consume data from Kafka, deserialize it from Avro, look at the metadata on the broker, look at the header information, timestamp. It's super, super flexible. Here I'm saying consume from this particular topic, -t to define the topic. The only thing with Kafkacat is you have to kind of get used to all these different labels of the configuration parameters here. But once you do that, or once, like I've got a cheat sheet or you've got it on your clipboard, it's really, really powerful. So we're getting the data out as JSON. If I just do JQ here, so JQ, if you're not familiar with it and you work with JSON data ever, JQ is worth your time investing and learning because it's really, really useful. So if I look at the data that comes from Kafkacat by default, it's just this lump. Let's cancel that and cancel that. It's just lumps of JSON, which is fine, and I can eyeball it or copy it and paste it into an editor and format it. But if we use JQ, so pipe it through JQ here, it just formats it nicely. And we can also start to go through and filter out different parts of the message. So here's what Kafkacat gives us. It gives us the topic, the offset, the partition, all sorts of rich information like that. And what we can see is, let's use Kafkacat and JQ here to say, just show me the payload part of the message. It says, well, okay, here's just part of the payload. We can see the product as it passes through. We've got lots of different values in that product. And for whatever reason, I would like to say, well, all this data in my Kafka topic, I would like to filter it when I egress it out to a target. And I would like to filter it just for where this product field here contains stout. So it's lots of different beers and whatnot in my dummy data here. If it contains stout in the product name, I would like to send that down to the target. If it doesn't, I would like to drop that record. So that's what we're going to do here with this configuration. And it looks like this. So data from this topic, We've got a transformation, we're going to call it filter stout because that's a suitable label, it describes what it does. And here is our transformation. So this is slightly confusing because previously we saw the filtered single message transform that comes with Apache Kafka, and it's called like org.apache.kafkaconnect.stuff.filter. Here we're using the filter transform that comes with Confluent Platform, which is called io.confluent.transforms.filter. So just be careful which one you're using here because this will cause you trouble otherwise. So here we're using the one from Confluent, we're applying it to the value part of the field, that's what the dollar value there is. And then for this single message transform, unlike the Kafka one, the Apache Kafka filter single message transform simply drops the record and you use it with predicates to make sure it does so based on the predicate evaluating. With the one from Confluent, we say we've got to specify the filter and then we specify the condition as part of the configuration for that single message transform. So here we say the type is include, so if we match the filter condition, which we're about to see, include those records. We could also set it to exclude and drop them if it matches. And then we say the condition, and we use something called JSON path here. So you go and read up on it and kind of figure it out. And what we say is if the product field matches a regular expression that looks like this. So our regular expression is between the two forward slashes, so anything ending in stout. So that we set running, and now the data that arrives in our target, which is going to be MySQL and a table called that, because the topic name is what defines the table name by default, we've not overridden it. So let's go into MySQL and have a look at our data. So show tables, and we've got one called day 11 sys01. So there's our data, that's what it looks like, and if we say select source and amount and product from that table, we can see as that data is coming in, if I keep refreshing that, you'll see we've got just fields here that match stout. So that's the filter single message transform from Confluent, matching based on a string regex on a field value on the message as it passes through. We could also use it to filter based on a numeric. Now here's where we have to be a little more careful, because if I do this, let's have a look at the data, let's remind ourselves what the data looks like. So here's the data in our source topic. We've got a field here called amount. So you may well say, I would like to filter on the amount being below a certain value. So if it's less than 42, then include that message as we write it out to the target. Now, by the by, we're starting to introduce quite a lot of business logic into our pipeline here. So just be mindful of, we're not just doing a bit of kind of like tidying up of topic names, we're actually applying transformation rules which are going to stop data passing through the pipeline. So if you like your target system owners start saying, I'm only seeing like small transactions in here and like nothing above 42, and you go and look at the topic in Kafka and say, well, I've got all the data in here, you have to remember that, oh yeah, we're filtering it out in that pipeline. Totally valid, but just be aware that it's like another point where your business logic is going to start residing. Anyway, so you say, I would like to filter out data on these messages as it passes through where it's less than a certain value. If you do this, so let's see what it looks like, you might well say our transformation, I'm just going to show you on the screen here and explain why it's not going to work. You say you're going to specify transformation, we're going to paste it into our previous connector definition, and we're going to say if the amount is less than 42, and you set it running, and Kafka Connect says, yep, that's absolutely fine, I'll accept that, I'll run with it, but it doesn't filter out any messages. And you think, well, what's going on there? Because it's totally valid and it's running and it's not throwing any errors. The problem is this. If we have a look at our data again, and pause that, the problem is this. The source data in our Kafka topic, for whatever reason, it's got that data held as a string. And so the filter that we're using, that JSON path thing, if you try and compare a string and say if it's less than a numeric, that really doesn't make much sense. So this is where we daisy chain our single message transforms, and we daisy chain them like this. So we talked on a previous day about the cast single message transform. So what we're going to do is we're going to say, here is the data from the source topic. We're going to cast it first, and then we're going to filter it. So the order is important. The order says cast the types first, and then filter. So here's our transformation for the cast. So cast types, the cast types has got a type. the type is do a cast in the value part of the message. The specification is cast the amount field to a float. And then when we do our filter here, so filter small order, that's the name of our transformation. The type, again, it's the Confluent filter, single message transform. The condition is where the amount is less than 42 and include those records. And this time it's going to work because the amount now, after that cast types single message transform here, that amount is numeric. So it's totally valid to compare it to a numeric. So if we set that running and we have a look at where it's writing data to it, so it's writing it to here. So we head over into MySQL. And if we say select star from this table, and it says, well, you need backticks on there. Let's just select the amount from here. And what we've got, let's actually just drop that table. So we've got the data from that previous one that I showed you where we were just pulling through stout data. So if I drop that table, so this is a heavy-handed way to do it, but the connector will see the table doesn't exist and recreate it. It's just dummy data. So when we requery it, we're going to see we've got new data coming through. So in the background, the connector saw the table had gone, recreated the table, and now populating it. And now we can see as that data is arriving in that table, it's only values less than 42, which is exactly what we wanted. So we've seen how you can filter data as it passes through Kafka Connect pipelines. We can filter data on its way into Kafka in source connectors. We can filter data on its way out of Kafka in sink connectors. We use the same single message transforms. We saw in Apache Kafka 2.6, Confluent Platform 6.0, the filter transformation that was added into Apache Kafka. By default, that filter transformation will drop a record. So it's designed to be used with a predicates capability, which was also added in the same release. And with predicates, you can say only apply a single message transform if a topic name matches a condition, if a header with a particular key is present, or if the record is a tombstone record. You can use predicates against any single message transform that you want to, but the filter one particularly is designed to be used with a predicate specifically. We saw how we could use it with other ones for like conditionally renaming fields. We also saw the filter transformation from Confluent, in which you can actually apply conditions based on the data in the message as it passes through. So rather than using predicates plus Apache Kafka filter, we just use the Confluent filter single message transform, and that lets you filter based on the data in the message. So it depends on what conditions you want to apply to your data as it passes through the pipeline as to which transformation you're going to use. Please do subscribe to the channel. It's great to see people enjoy this. It gives me good motivation to go and make more things. Do leave a message in the comments. Tell me if you found it useful. Tell me if there's other videos that you would like to see. Do make sure you check out our community Slack channel. There's a huge number of community members on there discussing all things to do with Apache Kafka and Confluent Platform. Stay tuned. Check out more of the videos on this channel and others to learn lots more about Apache Kafka and Confluent Platform.